Hello everyone. So in today's presentation we will discuss about a few problems based on Fourier series representation. Maybe in the last presentation where we discussed about certain properties of Fourier series, especially onto the continuous time signal with respect to the Fourier series, what we can call. And also one problem I just noted with respect to identifying Fourier series coefficient. And in the presentation, we'll discuss the few certain problems over here. So I'll discuss the second problem throughout whatever I considered from the previous presentation. So here the second problem. Its statement is like this: evaluate the Fourier series representation for the signal x of t is given. So signal is sine 2 pi t plus cos 3 pi t. There are two signals, sine and cos. Summation is there. So I have to find the Fourier series representation. In the sense, I have to find Fourier series coefficient x of k. I have to determine by the help of x of t. Then we can also represent its magnitude and phase spectrum also with respect to the whatever we calculate Fourier series coefficient. So let us try to identify x of k, the standard coefficient values with respect to the given x of t. So x of t is however it is taken in terms of sine 2 pi t uh, plus cos 3 pi t. We know that sine theta and sine cos theta values, how we can represent. Cos theta is nothing but it is e to the power j theta plus j minus theta divided by 2. Sine theta is nothing but I can represent it as e to the power j theta minus e to the power minus j theta divided by 2j. This is how we can represent. So same thing which we can implement for sine 2 pi t cos 3 pi t. If I substitute this particular condition, I can write sine 2 pi t as e to the power j 2 pi t minus e to the power minus j 2 pi t divided by 2j, plus for cos 3 pi t I can write e to the power j 3 pi t plus cos plus e to the power minus j 3 pi t divided by 2. So I just used these equation of these conditions. With respect to that, I just rearrange and I can write 1 by 2j e to the power j 2 pi t minus of 1 by 2j e to the power minus j 2 pi by 2 pi t, plus the second set of term is half e to the power j 3 pi t. Sorry, here it should be plus term. In terms of cos theta, it should be a plus half e to the power minus j 3 pi t. So please make a correction. This should be plus half. So here to here there is just written negative sign. So it should be a positive sign here. So comparing x of t, now this equation with respect to the Fourier series or Fourier series pair, what we considered, that is x of t and x of k relation. So I'll just take this equation with the standard equation Fourier series equation and I'll compare it. So the equation Fourier series says x of t is equal to summation k equal to minus infinity to infinity x of k into e to the power j k omega naught t. So if I compare this equation with x of t, so x of t is containing summation of 4 sets, either plus or minus, but it consisting set of 4 values. Out of that, each term consisting e to the power j k omega naught t for. So where we are going to observe, so omega naught here as constantly identifying as pi, as you can see. Even we can calculate the omega naught value, but along with that we have the term k also existing with respect to that, and remaining term is x of k, that is the Fourier series coefficient. This is what I can analyze it by comparing the expanded x of t along with the x of t Fourier series equation. So I can relate similar to this. So I'll move solution for this. So if I compare these two terms with respect to the values, so now as per that whatever I said, this is what the previous slide image, where x of t is simplified into the 1 by 2j to the power j 2 pi t minus 1 by 2j to the power minus j 2 pi t. So here what I can observe it comparing along with the standard equation, it says e to the power j k omega naught t, where k I can identify as 2. So if k is 2, then I can say x of 2 is x of k value should be this, so it is 1 by 2j. So x of 2 is x of k, that is 1 by 2j with respect to this. So if I say the second set of term here, e to the power minus j 2 pi t means k is minus 2. As per the standard equation we have e to the power j k omega naught t. So comparing to that, k should be minus 2. So x of minus 2, now it's having x of k value as plus, always should be there, but it is minus of 1 by 2j need to be considered. So over here if I take here, k value should be 3, so then its x of 3 should be a half. So similar to that last term over here, k should be, it is minus 3 here, so its x of minus 3 should be minus half. That's how I can take the Fourier series coefficient with respect to the given problem. So what could be the remaining k values? If I say 2, 3, minus 2, minus 3, I can get. So what is x of 0? What is x of 4? What is x of minus 4? What is x of 5? Minus 5. So that will be 0 for rest of the other values in terms of k value which we identified. So similarly, as I just mentioned earlier, so here I said with respect to the simplified term e to the power jk omega naught, so omega naught should be pi. I said let me calculate that omega naught over here. So how to calculate? I just need to identify what is omega naught for the first term. So sine 2 pi t, it's omega naught should be a 2 pi. So omega naught, we can take it as a 2 pi. So for the second term is cos 3 pi t, its angular frequency, that is omega naught, I can take it as 3 pi. So we have two term, the overall, the x of t is angular frequency, that is omega naught. How I need to consider? So it's a sum of these two term I considered. So I just need to take a GCD of 2 pi and 3 pi. So that will give the angular frequency of x of t. So GCD of 2 pi and 3 pi should be pi. So that's why I said omega naught is equal to pi for all the term. So that's how we taken the values. So next what I need to consider, if I want to plot the graph of Fourier coefficients, then I can go for with the magnitude and the phase spectra value. So magnitude of x of k, we can calculate it. So if I take the magnitude for x of 2, x of minus 2, x of 3, x of minus 3, so what could be the value? We will get half, minus half, its magnitude will be a plus half. So for all the cases, either x of plus or minus 2 or x of plus or minus 3, if I take the magnitude, I'll get half. The else remaining should be 0. Hence, the magnitude spectra, if I draw in terms of graph, then at minus 2, minus 3, at 2 and 3, we will have the value is half, rest all 0. So similarly, the phase spectra, if I want to able to produce it, then I just need to go for when k equal to 2, that is x of 2, what should be the phase value of this? This means it is theta is equal to tan inverse of the imaginary value, that is half in the numerator, divided by the real value of this term is 0. So half divided by 0 is infinite. So tan inverse at infinite, it should be a pi by 2. So when k equal to 3, if I take this value, this is real value. So theta equal to tan inverse of imaginary is 0, real value half. So 0 by half will be 0 itself. Tan inverse of 0 is 0. So angle is 0 when k equal to 3. So same thing which is going to be considered for minus 2 and minus 3 also. Same I can apply it. So after applying, I can find the phase spectra value only at minus 2 and plus 2 with an angle of pi by 2. This is what the phase spectra of the problem what I discussed is x of t is equal to sine 2 pi t plus cos 3 pi t. So this is how we find the solution. We got the Fourier series coefficients and also we got the magnitude and phase spectra of the given x of t. So I'll move further. I'll take another different set of problem. So the problem statement goes like this: determine the time domain signal corresponding to the magnitude and phase spectra is given with omega naught is equal to pi. So all the information is given that the time signal domain signals corresponding magnitude spectra is given and phase spectra is given along with omega naught equal to pi. So what I need to calculate? Time domain signal. That is, I have to calculate x of t, you have to find. So from the magnitude and phase spectra. So this is the reverse problem, or this is the reverse process what we done in the previous problem. So in the previous problem x of t is given, from that I found the Fourier coefficient, later I found the magnitude and phase spectra. Now I have to do in the reverse order. The given here is space and the magnitude spectra both is given, so I just need to go back in the reverse order. I can find Fourier coefficient, then I can find x of t. This is what the solution, how I can approach the solution for this particular problem. So let us look forward to the solution. As per the observation of both magnitude and phase spectra, the value of x of k should be existed only at 3 3 minus 3 minus 4 plus 4. So this is what we can observe it. So value at k is exist only at k exist at plus or minus 3 and 4. Rest all values will be 0. So from this I can say, so I just need to identify the phase, from the phase spectra and magnitude spectra I can find the coefficient value, Fourier coefficient value. So let me take at one particular point x of 3, let me take. So if I 3 consider, k equal to 3 I consider in the both magnitude and phase spectra. So at 3 we have the magnitude is 1 and the phase value is minus 3 pi by 4. The phase value is minus pi by 4. So what could be the expression then? So magnitude is 1 into e to the power minus j pi by 4, which we considered. So if I suppose I considered this particular term, how we need to be considered? That is the first thing which need to be understand. So over here we got the equation with respect to a 5 by 4. Then I should have the value should be equal to either 1 or more than that. So it should be, I should be able to get the value should be in terms of 1. So we can take the exponential factor with respect to minus j pi by 4. So however we taken the earlier case, the magnitude of theta which is equal to, however we considered the earlier value, the theta which is equal to tan inverse of imaginary value divided by the real value. Here theta is minus pi by 4. Take tan inverse to the other side. So tan of theta is tan of minus pi by 4. So what could be the ratio? It will be imaginary divided by the real value. So imaginary by the real value, so will be tan inverse of minus pi by 4. So from that I can able to identify the value of this ratios will be e to the power minus j pi by 4. This is how I can able to identify this polar values or polar form of x of 3. So from this I just able to understand x of 3 should be 1 into e to the power minus j pi by 4. So what about x of minus 3? So it is 1 into e to the power plus j pi by 4. So what about 4 at 4? X of 4 will be 2 into e to the power j pi by 8. At minus 4, x of minus 4 will be 2 into, that is e to the power minus j pi by 8. So this is how I can able to identify the Fourier coefficients. Once Fourier coefficients are found, then I can able to calculate the Fourier x of t value. So we'll try to understand, to get the from the Fourier coefficient the time domain signal. If I want to get, I have to use the equation x of t is equal to summation k equal to minus infinity to infinity x of k into e to the power j k omega naught t. So as we already calculated the values x of 3, x of 4, x of minus 3, x of minus 4 value already calculated, the value of k minus infinity to infinity exists only at 3 minus 3, 4 minus 4 values. So I can substitute the values corresponding to that. That is x of 3 we have the value is thus corresponding into e to the power j k equal to 3 omega naught. We already said it's given in the problem statement as pi. So pi t, that is what we can consider for x of 3. So at x of minus 3 we can take the value x of minus 3 is e to the power j pi by 4 e to the power minus j minus j 3 pi t plus next term is x of 4, so it is 2 e to the power j pi by 8 into e to the power j 4 pi t. That is what I need to consider. Next plus at x of minus 4, it is 2 e to the power minus j pi by 8 into e to the power minus j 4 pi for pi t. Okay, so then I just need to simplify this particular term. Out of that, I'll just take this term, I'll simplify the first term, e j e to the power j I'll just take, and the remaining I'll just write it inside the bracket. That is 3 pi t minus pi by 4. I'll combine these two together. Here same, I'll consider together, merge all together. So what I'll get, e to the power j 3 pi t minus pi by 4 plus e to the power minus j 3 pi t minus pi by 4. So what I can get in the inside, I'll have 3 pi t minus pi by 4 for both the term. So it is, look, e to the power j theta plus e to the power minus j theta divided by 2. If I do, it will be a cos theta term. So same for the second part pattern. So 2 common, 2 I can take outside, I'll simplify. So e to the power j 4 pi t plus pi by 8 for the second term, e to the power minus j 4 pi t. Here it should be a plus. Again, make a correction, here it should be a plus pi by 8. So the common term is e to the power j theta minus plus e to the power minus j theta. Divide by 2 if I do, then it will be also a cos term. So multiply and divide by 2 for both the sum term here over here. So 2, the divide by 2 here, it makes cos term. So 2 times of cos theta, that is 3 pi t minus pi by 4, over here divide by 2, multiply it 2, it becomes 4. So 4 cos, this is e to the power j theta plus e to the power minus j theta by 2. So I can take cos term. So cos 4 pi t plus pi by 8. So this is the final term I can get. So this is got these equation to this simplification with the help of cos theta is equal to e to the power j theta plus e to the power minus j theta by 2. So this is how we can again do the reverse process from the magnitude spectra or phase spectra, where I can calculate x of t value. So moving on to the next problem. So problem statement, let me look forward. Find the Fourier series coefficient for the periodic signal x of t with period t2 period 2 given by x of t is equal to e to the power minus t for t values lies from minus 1 to 1. So x of t is e to the power minus t, and the t values lies exist from minus 1 to 1 with the fundamental period is given t equal to 2. So these are the given information from the problem statement. So period, fundamental period is given t equal to 2. So I can calculate omega naught. Omega naught is equal to 2 pi by t. So t, if you say 2, then omega naught should be a pi. So omega naught is pi. We got omega naught value. But what I need to calculate, find the Fourier series coefficient. I have to calculate x of k value. So what could be the equation if I take x of k value directly? Here the solution, whatever we done earlier, the comparison of sine theta with respect to the all other values, which is not probably it is going to be equivalent. So e to the power minus only t exists, but in the previous problem, however, I can calculate sine theta or cos theta, whatever it is given, I can represent in the exponential and I compare and I can do, but here it is not possible. So the value lies only from minus 1 to 1. It is a periodic, however, so this is one particular set where the value exists, and remaining it is continuing going like this itself. So e to the power t minus 1 to 1, so 1 to 3, again e to the power minus t. So this is continuously, it is a 1 graph, it is going to be taken with the period of 2. So x of k value can be identified directly from the equation. So we have the equation from the Fourier series as x of k is equal to 1 by t with the integration over one fundamental period x of t into e to the power minus jk omega naught t dt. So if suppose I take this value, so here omega naught we just mentioned as pi, so I can substitute. But the fundamental period, however, I need to consider as minus 1 to 1, have to consider. T we already calculated or given, that is 2. So if I substitute even x of t we have, that is what given. So I can directly find x of k value with the help of this equation itself. That's why we can take the x of k value or x of k value can be identified with the help of the Fourier series equation. So I'll substitute for t value 1 by t. T is 2. Integration or one fundamental period from -1 to 1. It is defined. X of t you can take it as the given information, that is x of minus e to the power minus t into e to the power minus jk omega naught is pi t dt. So here you can further simplify the exponential terms combined together, e to the power minus of 1 plus jk pi of t dt under the and over the integration -1 to 1 range multiplied by the 1 by t, that is 1 by 2. So 1 by 2, take the integration of this e to the power minus j 1 plus jk pi of t divided by minus of 1 plus jk pi, that is the constant. Apply the limits, lower limit -1, upper limit is 1. So if you apply the limit, if you simplify, so what we can get, that is after simplification of term, we can get over here it is 1 by 1 divided by -2 of 1 plus jk pi into e to the power minus 1 plus jk pi minus e to the power 1 plus jk pi. So over this term, what I can consider, I can split this term e to the power minus 1 into e to the power jk pi, sorry, into the power minus 1 into e to the power minus jk pi, and second term minus e to the power 1 into e to the power jk pi. So these are the term, but over the two cases, e to the power jk pi, here it is plus 1 is going to be produced if k equal to 0, k equal to 1, k equal to 2. The value, if you substitute, the values are changing 1 minus 1, 1 minus 1. This is what we can change it with respect to e to the power jk pi. So say plus jk pi or minus jk pi, they are alternatively changing. One time it is plus, another time it is minus. So if I take that term combinations together, so it is gives plus 1 minus 1 in the alternate formations. So even minus 1 is outside. So all together, how I can write, if I take that minus sign along with that, so minus 1 to the power k. So when k equal to 0, the value is minus, this is going to be 1 itself. When k equal to 1, so minus 1 will get. When k equal to 2, it is become plus. So over here it is retained as it is. So the remaining constant term is e to the power minus 1. If I take minus 1 outside, it is minus e to the power minus 1. Minus, if I take outside, e to the power 1 is remaining as it is. So that I taken the minus outside, so minus minus become plus, but e to the power minus jk pi, e to the power plus jk pi, that will give this particular combination of minus 1 to the power jk to the power k. So divide by 2 1 plus jk pi. So this term we can get it with respect to the previous problem what we discussed out in the 4. So if I have x of t is equal to e to the power minus t or one fundamental period of 2, the range I just mentioned as -1 to 1, so it will give the Fourier coefficients x of k as -1 to the power k divided by 2 into 1 plus jk pi. It is again multiplied with the whole term multiplied with e minus e to the power minus 1. So for all the k values we can find this solution. So next problem is a statement like this. Find the time domain signal whose Fourier coefficient is given by x of k is equal to j delta k minus 1 minus j delta k plus 1 plus delta k minus 3 plus delta k minus plus 3, where omega naught is equal to pi. So I just have to find the x of t from the given x of k. So how to find x of t? So I can go for the equation x of t is equal to summation k equal to minus infinity to infinity x of k e to the power jk omega naught t. That is what the Fourier series equation, comparison between x of k and x of t for series condition. So from this I can say omega naught is pi, so I'll just substitute. But here given Fourier series coefficient are impulse values. These impulse values defined only at that particular point, rest of the values are not there. That is what the point which is mentioning. So x of k is defined at delta k minus 1, means it is a time shifted of delta k with one shift, right shift. That is the value of this k is again lies between of a delta k should be existed at k equal to 1. So this value delta k plus 1, this is the left shift which is observing with respect to delta k. So value should be existed at minus 1. So delta k plus k minus 3, this is the right shift of the delta k with respect to the vertical axis. So it is shifted to the right side with the plus 3 values. So it is at plus 3 we can take this delta k. So delta k which is existed here at a minus 3 left shift. So delta k value is at a minus 3. So k value existed at a plus or minus 1 and plus or minus 3 we can find from this given information x of k. So this is what I just able to take the note, and I just substitute it with respect to this particular equation. How we can substitute? So x of t is equal to summation, we said that k equal to minus infinity to infinity, but we said k value lies between minus 3 minus 1 and 1 and 3. So if I take those values as per the given problem statement, it is says j into delta k minus 1 minus j into delta k minus k plus 1. So that is the two term. Their magnitude value of delta k at minus 1 and plus 1 will be j and minus j correspondingly. So that's why the x of t substitution, x of k values existed as j is the magnitude with respect to k equal to plus 1. So e to the power j k omega naught t. Omega naught is pi, k is 1, j pi t is remaining with j minus j is going to be existed for the second term, that is when k equal to minus 1. So what we can take, that is minus j is the magnitude, e to the power j, k is minus 1, so minus j into omega naught is pi t. So this is what the term which is first two term of x of k. So the next term will be with respect to delta k minus 3 and delta k plus 3, where constant or magnitude is 1 there. So 1 into e to the power j3 pi t and plus 1 into e to the power minus j3 pi t. So this I'll just rearrange it. So here j common, e to the power j pi t minus e to the power minus j pi t, we can take it outside. If I will do multiply and divide by 2j, so what is going to happen? This is e to the power theta minus e to the power minus theta divided by 2j. So it will give sine term. So j into j square, that is minus 1. So minus 2 into sine theta, theta is pi t here. So minus 2 sine pi t for the second set of term together. So I'll take multiply and divide by 2 by 2. So what is going to be remaining? 2 as it is, but this is e to the power j theta plus e to the power minus j theta divided by 2. It is cos theta term, so it is cos 3 pi t. So this is how we can find the solution for the impulse response, whatever in the previous the problem statement. So the next problem statement is one more problem which we take an x of k is again given. So I need to identify x of t. So find the time domain signal corresponding to x of k is equal to minus half to the power magnitude of k, where omega naught is equal to 1. So I just have to find x of k. So I'll directly take x of t value directly. They will take the equation x of t is equal to summation k equal to minus infinity to infinity x of k into e to the power j k omega naught t. Omega naught is 1, so e to the power j k t x of k with the summation minus infinity to infinity x of t. So I'll just substitute it the value with respect to x of k. I just need to be substitute minus half to the power k magnitude. So magnitude, if I remove, the value can exist from minus infinity to infinity. But if I say magnitude, it is remained only 0 to infinity. But I cannot always substitute the value with the magnitude. So I just need to be removed when it is substituted for the summation term. Comes to the equation or substitution for the equation. So what we can take, the two set of term we can consider. How? So if I remove the magnitude, the value will be either negative also. If I have magnitude, it becomes a positive. So if I remove the magnitude, what is going to happen? It will be a minus term only over the range of k equal to minus infinity to minus 1. So this is what we can consider with respect to the magnitude. So two set of equation and on the positive or the negative side of the k values, which we can mention it. So when summation k equal to minus infinity to minus 1, so we can say minus half to the power minus k into e to the power jkt, as it is from the previous slide, plus summation k equal to 0 to infinity, I'll say minus half to the power k, because 0 to infinity it is going to be a positive value, because magnitude is, of course, it is defining at the positive, hence it is going to be positive e to the power jkt. So two set of terms need to be simplified here. So minus half to the power, if I change this notations, minus infinity to minus 1, I'll just make it to 1 to infinity. So if I want to make it, I just need to change the powers into the k values need to be changed, sign should be reversed. So k become minus k becomes k, here k becomes minus k, so the terms is reversed when the summation term, lower and upper limit are interchanged with the positive sign also, plus summation k equal to 0 to infinity minus half to the power k into e to the power jkt, as it is. So next what we will do, k common, I'll take it together outside, so minus half to the half into e to the power minus jt whole to the power k, over here minus half e to the power jt whole to the power k. So it looks like summation n equal to 1 to infinity alpha to the power n. So summation n equal to 0 to infinity alpha to the power n form it is looking. So with the help of that form, it is 1 by alpha by 1 minus alpha and 1 by 1 minus alpha term. So alpha by 1 minus alpha, so alpha here is minus half e to the power minus jt. So minus minus plus term which is existed here. So for the second also 1 by 1 minus alpha, alpha is minus half, so minus minus become plus half e to the power jt. So after simplifying this term, take common denominator and multiply to the numerator and simplify it, we will get to 3 by 4 divided by 5 by 4 plus cos t. So simplification term you can try it by taking these two terms and simplifying, you should get this as the final result whenever you take the given Fourier series coefficient x of k is minus half to the power k with the magnitude. It will give the time domain value x of t is equal to this. So the next one more problem I just taken. So plot the given signal and find the Fourier series coefficient for the given signal as x of t is equal to sine 2 pi t. So I have to plot, then I have to find the Fourier series coefficient. So plot of this signal, if I take t equal to, this is the magnitude which is considered. So signal is both in the positive and the negative side of the vertical axis or time axis. So if I remove this magnitude and also substitute the values for t, when t equal to 0, what is going to happen? T equal to 0, sine 0, 0 is 0. When t equal to something like 1, if I suppose take, what is going to happen? It is 2 pi. So the maximum value, so that is again going to be 0. But I can take the some minimum value less than 1 also, that is like half. If I take, what is going to happen? Half half, that is cancel each other. So sine pi is remaining, sine pi again 0. But what is the case? Further simplification is 1 by 4 for t value. What is going to be happen? Sine pi by 2, so that is equal to 1. So maximum. So when t equal to 1 by 4, it is giving maximum value 1. When t equal to 0, 0. When t is equal to half, it is 0. So one signal of a sine is completed. So this is repeated for every half duration. So fundamental period, I can consider it as half. So fundamental period t equal to half. So this signal is continuously either side positive or negative time axis. So we can find it, the signal of a sine functions over the fundamental period of half. So if t equal to half, what is omega naught? It is 2 pi by t. So 2 pi by half is gives 4 pi. So omega naught is 4 pi. So next what I need to find, plot is done. So I have to find the Fourier series coefficient. I have to calculate x of k. So I will go for the equation x of k is equal to 1 by t integration over 1 fundamental period x of t into e to the power minus jk omega naught t dt. So t we know that is half. So substitute the values, but the integration 1 fundamental period is 0 to half is there. So 0 to half you can take. X of t value is sine 2 pi t into e to the power minus jk omega naught. K omega naught is 4 pi. t dt. So this is what we can substitute. Let rearrange this equation. The lower term 1 by t, this denominator t half 2 goes above, so 2 remaining here. Sine 2 pi t or sine theta form, you can expand it. So we will, if I expand sine theta, then it will be e to the power j theta minus e to the power minus j theta divided by 2j. That is e to the power j 2 pi t minus e to the power minus j 2 pi t divided by 2j into e to the power minus j 4 pi kt dt. So integration with the limits of 0 and half multiplied by 2. So because 2 is nothing but it is the 1 by half, that becomes 2. So 2 to cancel each other, this j you can take it outside. 1 by j integration 0 to half, so you just multiply these term and multiply and write it together. So e to the power j 2 pi is common for both cases. 1 minus 2k is the term is remaining, t is also common. So for the second term also minus as it is, e to the power minus j 2 pi is common along with the t remaining inside is 1 plus 2k. So after these two multiplying together and simplifying it, then you take the integration for this and this term separately. So e to the power j 2 pi 1 minus 2k t divided by j 2 pi into 1 minus 2k over the limits of 0 and half minus e to the power minus j 2 pi 1 plus 2k t divided by minus j 2 pi 1 plus 2k over the limits 0 and half. This minus becomes plus. So the second term, after applying the upper limit and lower limits, upper limit will give some value, lower limit becomes one value. So the term is minus, so minus term which is existed. So this term, if you simplify it after multiplying 1 by j inside, j into j square, it is minus 1. That minus I'll take this, this becomes plus, this becomes minus. So 1 minus e to the power j pi 1 minus 2k divided by 2 pi 1 minus 2k. This 1 by j is multiplied. If I take plus as it is, j into j square, that is minus 1. Minus I'll take for this term. So this becomes plus, this becomes minus. So 1 minus e to the power minus j 2 pi 1 plus 2k divided by 2 pi 1 plus 2k. So this is how we can find the solution for the given one of the equation in terms of sinusoidal. So we saw the functions in this particular presentation. Few problems with respect to magnitude spectra to be, or phase spectra to be calculated by the given x of t values or x of k values. Though whatever I just able to find from the Fourier series coefficient, we can calculate from x of t, or from the Fourier series coefficient we can able to reproduce x of t values. So few more problems we will discuss in the for the next slide. Thank you for listening.